Hey guys, this is Mrs. Hardin, and today we are going to take a look at 10.2, solving right triangles. We've been working on learning the trig ratios. We've got 3 primary trig ratios and 3 inverse or secondary trig ratios. So let's do a quick review. You can use your calculator for this review if you don't have it memorized just yet. But what is sine 30 degrees? Remember, we're just wanting to know when we ask what is sine, what is the ratio of the side opposite the 30-degree angle compared to this hypotenuse of that right triangle. Sine is opposite over hypotenuse. You can just plug that into your calculator, sine 30 degrees, and you should find out that the ratio is always 1/2 or 0.5. Now, the inverse of that is sometimes we're given the ratio and we have to find the angle. So for what value of A or alpha does sine alpha equal 0.5? So now I want to know what angle has a ratio of 0.5, opposite over hypotenuse ratio. So to enter that into your calculator, you're going to use the inverse sine button. I want to know what angle has a ratio of 1/2 or 0.5, and when you put that into your calculator, you get 30 degrees. All right, let's try a second one. What is tangent 45 degrees? Remember, tangent is the ratio between the side opposite the angle and adjacent the angle. So what is the tangent of 45 degrees? 1. And then the inverse of that, what is the value of alpha? Or for what value of alpha does tangent alpha equal 1? Plugging that into my calculator, I want to know what angle has a tangent ratio of 1. So we'll do inverse tangent 1, and we get that the angle is 45 degrees. When the ratio of 2 sides in a right triangle is known, the measures of its acute angles can be determined. So the reason that we learn these trig ratios, sine, cosine, tangent, and then their inverses, is because it helps us measure angles and sides of a triangle without having to have, a big giant protractor or a big giant ruler. As long as we know the ratio of 2 sides in a right triangle, we can figure out the measures of the rest of the angles. So let's try that here in just a second. We can find the angle for a given value of the sine, what we just did, by using the inverse sine, or it's called arc sine. It's symbolized by sine to the -1 there. That -1 just means inverse, or arc sine x. Your calculator might have arc sine, but most calculators that I have come across, at least the ones that we'll be using, typically use this button. Okay, but if you use a different type of calculator, you may come across arc sine. They are the same thing. So if we know the ratio, we can use that inverse sine to find the actual angle. All right, we can do that for all 3 of our main trig ratios. So the inverse sine, if we know the sine ratio, we can use inverse sine to find the angle. If we know the cosine ratio, we can use inverse cosine to find the angle. And if we know the tangent ratio, we can use inverse tangent or arc tangent to find that angle. So if sine 60, the ratio of opposite over hypotenuse of a 60-degree angle is √3/2, then the inverse sine of √3/2 takes us back to our angle, 60 degrees. So we can use our calculator to go either way, to find the ratio, or when given the ratio, to find the angle. Solving a triangle means this: finding all of its side lengths and angle measures. So you may want to write that in the vocabulary section of your notes. Solving a triangle means finding all of its side lengths and angle measures. We're going to work on solving right triangles today. In a right triangle, if we know 2 sides, or if we know 1 side and 1 acute angle, we know at least those 2 things, then the remaining angle measures and side lengths can be found. Remember that in a 90-degree or a right triangle, we always know this angle. This is 90 degrees. In order to solve a right triangle, we either need to know 2 of the sides, any 2 of the sides, or 1 side and 1 acute angle. in addition to that 90-degree angle. So as long as we know that, we can solve the triangle. Remember, solving a triangle means finding all of the side lengths and all of the angle measures. So let's try this together. We're going to solve triangle A, B, and C. Notice that we know 2 of the sides. As long as we know 2 of the sides, we can find all the rest of the measures. So let's see. We know that the tangent of an angle is opposite over adjacent. And when I look at angle A, or this alpha symbol here, angle A, I know the opposite is 4, and I know the adjacent is 7. So I can use that to find my angle. Remember, if I know the ratio, I can find the angle. So I know the ratio is 4 over 7. So then I want to do the inverse tangent to find the angle. The inverse tangent of 4 over 7 will give me an angle of 29.7 degrees. We'll round to the nearest tenth. If I know that this angle is 29.7, and I know that this angle is 90, how can I find this third angle? Hopefully you remember that all the angles of a triangle add up to 180. So if I take 180 degrees minus 90 minus 29.7, I'll find the angle there. Or I know that these 2 angles, if my right angle is 90, I know that these 2 also have to add up to 90. So I can just take 90 minus my 29.7. So either way you go about it, you'll find that angle B, or beta, is 60.3 degrees. 60.3 degrees. Now, how could I find my missing side? There are a couple of different ways that I can find it. I can use the Pythagorean theorem. 4 squared plus 7 squared equals this hypotenuse squared. I could also use trig values to find that missing side as well. But for our example today, we're going to use the Pythagorean theorem. 7 squared plus 4 squared equals c squared. That's our hypotenuse here. Remember, it's opposite angle c, so we call it c squared. I get 65 because 7 squared is 49 and 4 squared is 16. So 65 squared equals c squared. In order to get c by itself, I have to undo the square under the exponent. And taking the square root undoes a square exponent. Whenever I do to one side, I have to do to the other. So c is equal to the square root of 65. I'm going to see if I can simplify that any more. Thinking about, are there any perfect squares in there, like 4 or 9 or 16? There aren't any perfect squares, so we're going to either put 65, square root of 65, or if we're asked to write it as a decimal, we can write 8.1. 8.1 is our measure of that side. All right, so we have solved that triangle. We found all 3 angles, and we found all 3 sides. In class, I'll show you another way that you could find that side using the trig ratios if you didn't want to do the Pythagorean theorem, although the Pythagorean theorem is typically what we use to find the missing side. All right, so a couple of things. Remember that there are some special triangles. You learned about these in geometry, so hopefully you remember some details about them. But knowing these 3 special triangles, or these 2 special triangles, will actually help you quickly determine trig values of 45, 30, and 60 degrees without a calculator. In fact, by the end of this year, you will know the trig values of these 3 angles from memory. So we're going to go ahead and take a look at them right now. If you remember, in a 45-degree triangle, both of these angles are the same, 45 and 45, which means our 2 sides also have to be the same. Using the Pythagorean theorem, we see that our hypotenuse is whatever our side is times the square root of 2. Now remember when we did different size triangles the other day, we found out that the trig ratios were the same no matter how big the triangles were. If we reduced those fractions, those trig ratios, they kept giving us the same fractions or the same ratios. So if this side is 1 and this side is 1, then this is hypotenuse is 1 square root of 2. If this side were 2 and this side were 2, what would the hypotenuse be? Hopefully you said 2 square root of 2. If this side were 3 and this side were 3, what would the hypotenuse be? 3 square root of 2, and so forth and so on. So the trig ratio is always going to be the 2 legs are the same, and the hypotenuse is the leg times the square root of 2 in a 45-degree triangle. In a 30, 60, 90 triangle, okay, and again, no matter our sides, they're always going to have this ratio. But if our 30-degree angle gives us a side of 1, our hypotenuse is always going to be double that, 2. And our third side, our leg, will be the short side times the square root of 3. So 1 square root of 3. If the side opposite my 30-degree angle were 2, my hypotenuse would be double that, which would be what? 4. And my long leg would be the short leg times the square root of 3. In this case, 2 square root of 3. So we could reduce those, and they would still give us that same ratio. 1 to 2 is the same as 2 to 4 or 3 to 6. So if we can remember these ratios now, it will help us later. But eventually we will have these ratios and all of these trig values memorized for these particular triangles. So let's try solving triangle ABC. I've got a 45 angle here, 45-degree angle here. So I know right off the bat what angle A must be. I know that angle A must be 45 degrees. In a right triangle, my two acute angles have to add up to 90. I also know that in a 45-degree triangle, angle or side A and side B are the same. My two legs are the same. And going back here, my hypotenuse is the leg times the square root of 2. So my hypotenuse is the leg, let's say leg A, times the square root of 2. So I'm going to go ahead and write that equation. I know, first of all, angle A, 45 degrees, so we already have done that. And I know that my hypotenuse, which is 5, is equal to the leg times the square root of 2, or A square root of 2. Now I just need to solve for A. I'm going to go ahead and remember the implied operation is multiplication. So in order to get the A by itself, I've got to undo multiplication, and division does that. So I'm going to divide both sides by the square root of 2. And when I do that, I get A equals 5 over the square root of 2. Now, I can't leave square root of 2 on the bottom. I need to rationalize my denominator. I don't want to change the values, so I'm just going to multiply this by 1. And remember, another way to write 1 is any number over itself. So I'm going to multiply this by root 2 over root 2. Working across the top here, 5 times square root of 2 is 5 square root of 2. And square root of 2 times square root of 2 is just 2. That's how you get rid of the radicand or the radical symbol down there on the denominator. So I find out that my A is 5 square root of 2 over 2. And because in a 45, 45, 90 triangle, I know the two legs are the same, then I also know that side B is 5 square root of 2 over 2 as well. All right, let's take a look at our 30, 60, 90 triangle. If this is 90 and this is 30, then I know my theta here must be 60 degrees. So we're going to start by solving that. I remember also that the side opposite my 30-degree angle is my short side. And my hypotenuse is 2 times my short side. So if my short side is 8, then my hypotenuse is 2 times that, 16. I also remember my long leg is the short side times square root of 3. In this case, my short side is 8, so my long side is 8 square root of 3. And I didn't have to do any computation other than 2 times 8 and 90 minus 30. All of that is just a pattern that's been recognized, and I'm plugging in my numbers. So as long as you remember those patterns, it will really help you solve those 45 triangles and the 30, 60, 90 triangles. A couple of definitions really quickly here. We can use trig values to help us solve for specific angles and word problems. Right? If you are looking straight ahead, we call that a horizontal line. Sorry, my line is not very straight. And if you tilt your head down from your horizontal line, this is called the angle of depression. Depression is looking down. And if you are looking straight ahead here, this is our horizontal line, and lift your head up to look up, we call that the angle of elevation. The line between 2 points is called the line of sight. So looking down, you've created an angle of depression, looking up, an angle of elevation, and looking from person to person, a line of sight.